Hello students, in this video we are going to discuss Cbse class 9 maths chapter 1 number systems, and we are going through the part 13 in this chapter. We have discussed 12 parts and we have also completed exercise 1.1, 1.2 and the sums related to these exercises, the examples as well as the concepts. Hope you understood that. If you have any doubts, please get back to those videos and try to understand, children. Now we'll get into the fifth example. So here we are starting with real numbers and their decimal expansion. So we learnt about real numbers in the previous video also. So what did we see about real numbers? We saw that it had both your rational numbers and your irrational numbers, isn't it? I hope you must be clear with what is rational and irrational. So rational, you will have all your whole numbers, natural numbers, and then your integers and also your fractional expressions. So wherein it is going to be a repeating and terminating decimal. It is going to be a repeating and your terminating decimal. So with this, you will be able to say that your irrational numbers are decimal expansions which are non-repeating, or you can say they are going to be non-terminating. So let us try to find out the decimal expansion of these, and we'll try to categorize if it is going to come under rational numbers or irrational numbers. So we'll do all these three one by one by just simple division which you all learnt in your lower classes. So when you have this, what you will do generally, you will put the numerator inside and the denominator outside, isn't it? Same thing we're going to do now. First we'll do for 10 by 3. So you have 10 inside, so you have 3 outside. So 3, you know it, 3 3s are 9. When you subtract it, you will get 1. So you don't have any number here. So what you will do is you will put a decimal and then you will put 0. So again you have 3 3s are 9. So again it's going to go on repeating. So if you see here, how much ever times you do, you will only get 3.33333. So your answer here, you can say it is going to be 3.333. Also, you would have learnt in your lower classes that if a number, that is a decimal, is going to continuously repeat, how much ever times it repeats, you're not bothered, but whichever number is repeating over that, you will put a bar. So here this 3 is only repeating after the decimal. So you can also write it as 3.3 bar. So I hope this you would have learnt in your 8th standard. So now what is this? This is going to be repeating. It is going to be repeating decimal. So now this is going to be a rational number. It is going to be a rational number. So now let's get into the next one. First we have completed 10 by 3. The next one is going to be 7 by 8. Even if the numerator is going to be lesser than the denominator, remember that the numerator should always be here, the denominator will always be outside. We're going to divide the numerator by the denominator. So put a 7 here and you have your 8 here. Now, you know that 8 is going to be greater than 7. So you want to put a 0 here. So you have a 0 and then a decimal. So you put a 0, you know that. You will know for 8 table, you will know it's going to be 8 8s are 64. So 70 minus 64 will give you 6. So now you put another 0. So you will have from 8 table, you will again say that 8 7s are 56. Your balance is going to be 4. You put another 0. Then you can say that 8 7s are 40. Here the remainder is 0. If the remainder is 0, then you can say that this is going to be a terminating decimal. It is going to be a terminating decimal. If it is going to be a terminating decimal, then it is also going to be a rational number. Have you understood this, children? So we have one last sum here, 1 by 7. The same like how we did now, we are going to do for this also. So you put 1 here, you are going to divide it by 7, it is going to be greater than 1. So you put a 0, so 0 point, so 7 ones are 7, okay. So then you have 3, so you put a 0, so you have 7 fours are 28. So now again you have 2, you put a 0, so you have 7 twos are 14, your remainder is going to be 6, you put a 0, 7 eights are 56. Again your remainder is 4, you have a 0 here, so 7 fives are 35. Generally when you come across these kind of questions, when the decimal is going to keep on changing, we will get an intention like this is a non-repeating, non-terminating decimal. Okay, but there is a small twist in this, that it is going to be a repeating. Now I'll tell you how it is. So you have 5 here. So now again you know that it is, you can know the 7, you're going to put a 0 here. So 7 sevens are 49. You again have 1, you put a 0, you're going to say 7 ones are 7, so again you have balance 3, so 0, 4. So now at this point you can say that it appears to be repeating. See, so at this point you can see that here you have 10, here you have 10. Again the same 30, again the same 30. So you can see that it will again keep repeating. So how will it keep repeating? Again you may have, so after 1, 4 you will have 2, 8, 5, 7, 1, 4, 2, 8, 5, 7. So it will go on repeating, but it is going to repeat as a pattern. So how will you write it is, so 1 by 7, the decimal expansion will be 0.142857142857. When we saw the first one for 10 by 3, I told you when you have 0.333, I told you we can put a bar here. But it is a pattern. Where is the pattern repeating? After this. So you can put a bar after this, 2857. You just put a bar here. It means that the entire pattern will again repeat like this. After this again it will repeat. So now this is going to be a repeating and a non-terminating. Okay, it is not terminating, so it is going to be a repeating and non-terminating decimal expansion. So if it is repeating, what is it called now? It is again called to be a rational number. So thus we have done all the 3 questions. So what did we have is, so for 10 by 3 you had the remainder not equal to 0 and the value was 0.3 bar, and for 7 by 8 you saw that the remainder was equal to 0 and the value was 0.875, and for 1 by 7 again the remainder was not equal to 0 and the value was 0.14285 bar. So you can find that all these 3 are rational numbers. So we will come across the other examples where you will even have irrational numbers also. When we do that, I will be explaining you this. Okay. So we have all these things. So if it remainder is 0, surely it is going to be a rational number. The remainder never is 0 and it is repeating, then also it is going to be a rational number. So thus we have completed with the example 5 in this video. I hope you understood this. If you have any doubt in the concepts, please get back to the videos where we have the concepts explained regarding the rational and irrational numbers. See you again another video with another concept, children. Thank you, children.